Good afternoon, everyone. We'll go ahead and get started in just 1 minute. So as I was saying, good afternoon and welcome to Space Center Houston. We're so honored to welcome the remembrance and reunion of STS-5 and to have you guys here in our house. It's our pleasure to host this event, and we love hosting these opportunities both for our guests and for our alumni and for our Johnson Center and current employees as well. Hopefully while you're here, you have the opportunity to visit Destination Moon and see the Apollo 11 capsule. And then you'll get the chance as well in Starship Galleries is the Apollo 17 capsule. So the only place where you'll see the bookend capsules of the Apollo mission. So we're so honored and privileged to have that. And without further ado, here is Rob.
Good afternoon. My name is Rob Kelso. I'm on the board of directors of the NASA Alumni League, who is sponsoring this celebration event. I was also a payload officer on STS-5 with Mike Hawes. We are so glad you're here. What a joy it is to have this opportunity to celebrate the 35th anniversary of STS-5. Of course, this is really a historic month. I mean, last night, Houston wins the World Series. That's amazing. And then here today, we have a number of celebration events for STS-5. Tomorrow is the 60th anniversary of the first animal in space, when the Soviet Union launched November 3rd, 1957, Laika, female Russian dog, into Earth orbit. And then November 9th, in a few days, the 50th anniversary of the first integrated full-stack launch of the Apollo Saturn V, Apollo Saturn 501, Apollo 4. But today we focus on the 35th anniversary of STS-5. My thanks to Chance and also Tracy for their great help in letting us come here. Same area that we used with the Apollo Flight Operations Association reunion back in July. We're back here again for STS-5. Let me begin today's session with introductory remarks with Mr. Abbey, who is Director of Flight Crew Operations Directorate, later Director of the Johnson Space Center. Please join with me in a warm welcome for George Abbey.
Well, thank you, Rob. It's very good to be here and reminisce about STS-5. And 35 years ago, back in November 1982, I don't think very many people would be thinking about having a reminiscence session 35 years later. But here we are. We had flown 2 shuttle flights that year. We flew STS-4. It landed out in New Mexico, and STS-5 in November. And previously we'd flown STS-1 and 2 in 1981, both landing out at Edwards. So 35 years have gone by since STS-5. 29 years out of the 35, we continue to fly the space shuttle. And it proved to be a great machine and probably could be flying much longer than we flew it, and probably ought to be flying today. It was a very flexible machine, gave us great capability, and we already have been missing it very much over these past 6 years, with the last flight occurring back in July of 2011. It was designed by the people that really developed and gave us the Apollo program, and they got away from capsules. They came up with a flying machine that could operate in space but also could land on a runway. And I think they had the right answer then, and it's the right answer now. So as you look at flying in space, and if you're going to really do more in space, we have to reduce the cost of launching. And I think companies like SpaceX and Blue Origin, and with the recoverable boosters, are going in the right direction. But also there's another shuttle-like vehicle flying. It's flown already a number of times in space, the X-37, and it's flown very successfully. And I think if we did it the right way, we could scale it up and get back to flying a machine like the shuttle. And I think that would give us a great capability, and teaming it with the recoverable boosters, we'd have a recoverable system that we really wanted to do when we started out with the Space Shuttle program. It, as I say, it was a great program. We flew a number of great missions, and for the first time on STS-5, we could fly more astronauts and take advantage of some of that capability that existed in the shuttle. And we did that on STS-5 with 2 mission specialists, and Vance and Bob Obermeyer. And you're going to hear about that mission this afternoon, and I think it'll bring back some good memories to us all. So let me hand it over to Vance.
Great to be here today. First thing I want to say is give a big yay for the Astros. Well, we live out in California, but we remember all those years that we were pulling for back 20 or 30 years ago, so it's a wonderful thing. We had, as George said, a crew of 4, and so it was the first mission to do a few things. First mission to launch satellites into high orbit, geosynchronous orbit. First mission to have more than 2 crewmen. We had 2 ejection seats still in the plane, or in the spacecraft, but the ejection seats were pinned, so they weren't usable. So it was the first time that we depended on the shuttle to be very reliable, with scant chance of escape if something went wrong. And we were the first operational mission, quote-unquote operational. In some ways, the shuttle was experimental till the very end. I always wished that the shuttle could have gone a few more years, because I thought that most of the problems were worked out. But it was a marvelous machine, and so we sort of were the first one to make that machine into something that would carry useful payload into orbit and be operational. I guess I ought to show you the movie. I'll narrate it in one or 2 places. I may break in and let you hear the banter that's going on, because we've lost 2 of the crewmen that were on that mission. We lost Bob Overmeyer and Bill Lenore, and I had just an outstanding crew. They were Joe Allen, Bill Lenore were they were true scientists and engineers, and they really worked the payload problems along with everything else. Bob Overmeyer was a great pilot, and unfortunately he died in testing an airplane a few years later. Well, let's start the movie, and I'll talk about it a little bit. So a third of you can watch the left screen, a third the right. Okay, this was November 11th, 1982, liftoff. As you know, the main engine started 6 seconds before liftoff. Then the hold down's released, and solid rocket boosters started. So it was my first liftoff in the shuttle. I'd had one in Apollo-Soyuz, and the two were fairly similar. In a way, ascent was very similar to in both vehicles, but entry and landing were quite different. Okay, we went 2 minutes on the solid rocket boosters, a lot of shake, rattle, and roll, a lot of noise, and we had on motorcycle helmets, so we back then we got away from the pressure suits and just wore coveralls and motorcycle helmets. And a little over 2 minutes, here are the solid rocket boosters burning out. And, of course, coming down on parachutes to land and be refurbished. Once we got on, well, let's watch the landing of the SRBs first here. Parachutes coming out. This was off the Florida coast. Slowed the vehicles down considerably. Had a cloud deck to go through. In a minute you'll see splashdown. And that's it. Of course, the SRBs were empty of propellant, so they floated, and the parachutes were released. And a pickup ship will come up shortly and get them. Pretty dramatic event in itself. This shows after we got out of orbit. By the way, this is the main tank, or the tank being released on orbit, shortly followed by OMS 1 burn and OMS 2 burns to establish us in a 160-mile orbit, nautical mile orbit. This is looking in the cabin from behind the front seats. And here you're getting a view of the ocean. We were in a standard 28 degree equatorial orbit, and here we are transforming the shuttle from a flying machine into an on-orbit platform to do useful work. You're looking back here, and you see the covers that have the two rockets to be deployed. We're closing the cover sun shields. We had to deploy two satellites on that mission, and they were commercially developed satellites. There's Joe Allen, and he was always a joy to have on board, and very competent. Now, sun shields are being folded back again, and very soon the satellite and booster rocket will be spun up. There it's starting. So that after release from the shuttle, they'll be stabilized before 45 minutes after release. They will be sent up by their own rocket power into high orbit. And that's the release of the satellite. Here it is going away from the shuttle. everything worked great. Just can't say enough for the people in several places that made all this happen, and it went so well. We had 20-some flight tests and quite a few what we called DSOs, which were human body tests too. Bill Lenore is strapped to the floor and has sensors on, and Joe is performing a test here. We had a treadmill. When we walked on the treadmill, it shook the whole vehicle. It always surprised me, and but we tried to get our daily exercise. Here we are. Well, it's eating time, and so that's me on the left. We had food, of course, at standard fare, freeze-dried mostly, some military. Bill Lenore has given us a few zero-G tricks here. Joe Allen is going to eat something. Showing you this movie to kind of get you thinking in the direction of what we were doing up there and what was going on in our mission at that time. So it was really fun, of course, as everybody says, looking down to see what you could see on Earth, places you'd read about or heard about or been, but you could see them all connected on orbit. And, gave you a real appreciation of the smallness of the Earth in a way, because you can go around it in 90 minutes. Here's Joe Allen and Bill. Now, Joe deployed one of the satellites and Bill the other. This is our second satellite going up. It was released and spring force pushed it out of the vehicle. You're looking back at the two OMS pods with the vertical fin in the middle. So 45 minutes after release, we turned the vehicle around so that the underside faced the blast, and a timer went off and started the rocket engines for the satellite. Here we have more on-orbit antics. It's really, really quite nice being able to move around that way unless you have something serious to do, like, well, for example, screw something into the wall, in which case you want to have foot restraints or wrap your leg around something to stabilize your body. Bob Overmeier's the upside down guy. Bob and I were ex-Marines, and so there's always a lot of joking about how could ex-Marines understand scientists and real engineers. It looks like chaos, doesn't it? Well, something after deploying the satellites and doing all of the experiments and all, there was something else going on, and that was to have an EVA. Actually, the first EVAs by the two mission specialists out of the shuttle. And they got good training on that, and they were all primed to go and wanted to be the first. And so they were looking at some of the gear back there. But here's more walking on the treadmill. It's funny how quickly your body degrades just a little bit up there. So that treadmill exercise was very important. There's a lot of photography. I think we got around 2,000 shots of the Earth and things going on in orbit. And here we're getting ready for the EVAs. Well, unfortunately, after the guys had the suits on and were primed to go outside, we found that the suits failed test. Each suit did, and so the EVAs were canceled. And the honor of having the first EVA on the mission defaulted to the next flight, STS-6. So we have one crewman all set to go outside. EVA is fairly common now, and I think we understand an awful lot about it. You have to remember that back then we had the experience that had come from Gemini, and that was about all as far as EVA was concerned. So we were fairly cautious back then, and a couple of suit problems weren't tolerated. Well, this is closing the payload bay doors again. You'll notice that the satellites are gone, and the doors came down, were latched. Then we started very soon after that preparing for deorbit. It wasn't a very long mission. It was around 5 days. But we did a lot in the time we were up there. There's a lot of thermal testing on the vehicle, for example. In one case, we sat with one side to the sun and one side in the shade for a very long time, around 40 hours, and dew formed on the shady side. And so when we ran on the treadmill, it rained. It shook the vehicle, and it rained in the vehicle. This is getting ready for deorbit. And it was to be a landing on the runway at Edwards Air Force Base in California, runway 22. Here we are, just starting to hit the top of the atmosphere, and you can see windows lighting up a little bit. Bob Overmeyer, who worked in steel mills, said it was like being in the middle of a blast furnace without the heat. And here we are coming down through a slight overcast up around 10 to 15,000 feet, coming down in a steep glide. And when we reach 2,000 feet, we'll do the pull-out maneuver and transition from a glide slope of about 17 degrees to a glide slope of 1.5 degrees. There's some water on the lake bed, but we're not landing there. We're going, as I said, to the runway. we'll bring the landing gear down at 500 feet. And touch down early in the morning on November 16th, 1982. Back then, we didn't have a drag chute on the orbiter, but we were somewhat in a flight test mode still after the first 4 shuttle flights, and one of our tests was to apply maximum braking during this rollout. So I stomped on the pedals, and we came to a stop, but when I released the brakes, fragments from the brake discs and all fell to the concrete. So we found out that they needed to change the brakes. Here we are, coming down to meet our boss, George. And each of us is about 1.5 inches taller because we've been in weightlessness for a while. Well, so much for the movie. Just a couple of other comments. I thought back then we just had a marvelous team. 3 centers, Marshall, KFC, Johnson, and everybody did a great job making the ship ready and all the plans. Payloads ready. Everything went, even though you always had little things go wrong. That's about every mission. Because of the complexity of the shuttle. Everything went very well. And I thought it was a landmark mission. And many of you in here played a part in that. So thank you.
Thank you, Vance. We have time for some questions, but before we do, while you think of some questions, is Chance still in here? So maybe we can use a mic to go down to the floor as well for those that might want to ask Vance a question. After we're through with this, we're going to take a short break while we reconfigure up here and bring up our panel for a discussion on other aspects of STS-5. But I thought it was really interesting, a number of firsts that are represented by STS-5. It was not only the 5th flight of the shuttle program and the 5th flight of Columbia, but the reason that we're here today is that was the first not only operational flight, but the first flight in the manned spaceflight program where we flew commercial payloads, launched commercial, in this case, satellites, as a part of the National Space Transportation System. And it was as a part of the first operational flight, as Vance mentioned, I think George did too, the flight of 4, it was up to that point the largest flight crew that had been launched on a U.S. spacecraft up to that point. It was interesting also, Vance pointed out, that on STS-1 through 4, as a part of the Orbital Flight Test Program, OFT program, the crews were just 2 in number for STS-1 through 4, and they wore the orange pumpkin suits. And this is the first flight, STS-5, where they moved away from the pumpkin suits into the what became later the blue jumpsuit for launch, entry, and landing. But also the ejection seats, as Vance mentioned, were active on STS-1 through 4, and with a flight crew of 4 now, it wouldn't be fair. There was no doubling up in the seats in case of emergency. So the ejection seats were deactivated but still in place for STS-5. And then they added 1 seat in the flight deck and then another seat down in the mid-deck, close to the hatch, I think. And then Joe and Bill alternated between ascent and entry in their position. Mike Hawes is going to talk a little later. The two satellites, ANIC from Telesat in Canada, and International Satellite, and then Satellite Business Systems, SBS-3, was the other satellite launch with that. But each of those was a Hughes HS-376 series communication satellite with a booster rocket attached to it, a McDonnell Douglas payload assist module that was at the time called the spinning solid upper stage, as you saw, spinning up to about 50 revolutions per minute to give it stabilization at deployment. So both of those represented significant milestones in the shuttle program. And it was also to be the first flight of spacewalk. Maybe Tommy will talk a little bit about that. And in addition, and maybe Vance will talk about it a little later in the panel discussion, it was the first in-flight maintenance ever to be performed in the shuttle program when CRT-2 failed on flight day 1. And maybe Mike will talk a little bit about how he and John Cox worked around the procedures with the loss of CRT-2. But you did an in-flight maintenance to recover that prior to entry.
A lot more on CRT-4.
Oh, for the deploy. Yeah, CRT-4 in the aft station. And then the other thing that I noticed was that STS-5 was the first flight to move back into FICR-2 or MOCR-2. The first 4 flights in the shuttle program were out of the second floor MOCR, and STS-5 moved back up to the third floor, which is the historic MCC MOCR from Apollo 11, Apollo 17 that is now undergoing restoration. STS-5 was the first flight to move back up into FICR-2 for a mission in the shuttle program. So with that, let's see if there's some questions for Vance or Mr. Abbey. And after that, then we'll take a short break while we reconfigure for our panel.
Vance, Ken here. Welcome home, at least temporarily. I'm holding down El Lago for you.
Good.
Since this was the first flight for the other 3, I think, I'm pretty sure, and you'd been on ASTP, of course, did you give them any tips ahead of time that, how to handle, say, nausea on the first day or anything like that? Were you able to impart some of your experience on ASTP to them?
Yeah, I tried.
Well, knowing those 3, they didn't listen to me.
But some of that, everybody had to learn for themselves. For example, we had a couple of cases of short space sickness, which kind of follows the statistic that about half the people that go into space in adapting to weightlessness get a short bout of sickness. Well, I'd never had that in the past, but for a short time I could see how miserable a couple of the guys were. So that was kind of an learning experience for me too. Yeah, I was the only guy. I had one flight under my belt, and they were all new guys. And so we talked all the time, and I hope that did some good. But you got to remember that these guys were all pretty experienced in airplane flying by the time we went up on STS-5, and had been in the space program for several years, so not too much of that was needed.
Mary Ann Dyson. I was FAO. And our biggest problem we had to work on this flight was the loss of the coffees. Bob Overmyer couldn't find them. I don't know if you remember this. And he accused you of having hidden them from him. And so I know he's gone, but he's probably listening from heaven. I just wondered, did you ever find the coffees, his missing coffees, or do you remember anything about that? The flight was so nominal. We were joking in Mission Control that this was the biggest problem we had to work.
You're asking about the coffee drinking.
Well, it was he had, I guess his had cream in them or something, everybody else was drinking it black, I think, or something,
Oh.
and he couldn't find his coffees, and he said that you all had hidden them from him. We thought this might have something to do with you being Marines, but we weren't sure. I just was wondering if you could clear that up for us.
Yeah, well, that particular thing I don't remember very well. What I do remember is that everybody's taste changed a little bit on orbit. I'd always been a black coffee drinker, and suddenly I like tea. And I'd never had tea.
The truth comes out.
Much in my life, but so there were little. And I don't know how you can explain that, but there were some changes in taste. Yeah.
Hi, I'm Elaine Sade. Nice to see you again. We used to play volleyball together. But anyways, you had said that the treadmill, you could feel the vehicle rumbling. I was wondering what it felt like when the satellites deployed, whether that shook the vehicle at all, or.
No, it didn't. It didn't really jar the vehicle. At least, if it did, not very much. You know, there are some things that were really noticeable. Obviously, liftoff, where you got kind of a tick in the back, and staging. There was noise, there was a bang, and visual effects, and so that was really noticeable. Also a little bit of jarring, I think. But as far as deploying the upper stages, they were deployed by springs, which gave them a relative speed of only about 2 or 3 miles an hour compared to the shuttle. So that wasn't very noticeable.
Norm Chaffee from engineering at the time. Did you guys, and maybe for George also from the program standpoint, were you guys completely convinced that OFT was complete and this was time to go ahead with a commercial flight?
Well, George, yeah, we thought, I think management at NASA headquarters was pushing pretty hard for the transition to operational flight. But we thought it might have a little challenge, but we were looking forward to the challenge and hoped that it would work out. And as it turned out, there were always some things to fix, but it did work out pretty well.
I think there was a lot of pressure to get a higher flight rate, and that wasn't really realistic. And we tried to tell people that wasn't going to happen, and they still push for it. And there's a lot of risk in flying a shuttle anytime you fly. It doesn't change too much depending on what kind of payload you put in it, except putting a Centaur, that does change it a lot. But you still have to pay attention to detail, and you got to be right every time. So it doesn't get any easier whether you make it a commercial flight or whether you make it a test flight. It still has that same difficulty that's always there, and you got to do it right and do it right every time. And unfortunately, that didn't happen on 2 occasions.
A little bit of a similar question is, what were the requirements that had to be fulfilled in the other 4 flights to convince us that it was safe to remove the ejection seats or disable the ejection seats? Of course, they weren't removed till later. So were there any special requirements that had to be fulfilled, and was it just flight demonstration or other criteria?
Yeah, I can't, after 35 years, give you a very good answer on that. But from our point of view, it was just accepting the fact that and thinking about what you would do if you had to get out of the ship. And people were more looking at it as an airline, in fact, thinking that this is going to be like an airline operation in space. And I thought they could get rid of the seats, and I don't know, maybe George knows more about what the requirements.
Well, I think we felt that there was a need to have escape provisions, but putting those into a vehicle like the shuttle was very difficult. The ejection seats really didn't cover the whole flight regime. They gave you minimum protection, but you really needed to make some changes if you wanted to have really that kind of a capability. And I think, again, there was a lot of thought that we could have a commercial type operation and fly a flight rates that weren't realistic, and that didn't turn out to be the case.
You spent a lot of time training with your crew beforehand. Then you had 4 guys on orbit for 5 days or so. Was there anyone that ever wanted to go off in a corner at some point and just be by themselves for a little while? Did it get irritating always being around somebody all the time?
Well, first it was impossible. Both on orbit and beforehand. On orbit, you had a very small room, a couple of rooms that you were living in. And, but nobody had that impulse as far as I know. What I remember is instead of going inside themselves and backing off into a corner, anybody that felt strongly about something would just come out and say it and argue it and keep talking about it. You have to understand that these 3 crew members I was up with were really bright and well-versed and unafraid of verbal combat.
Let's give a warm thanks for Mr. Abbey and Vance Brown. We're going to take a short break to reconfigure up here and invite our panelists up to talk about some interesting STS-5 stories from different perspectives: policy, program integration, and training, and more. So we invite you to stay in here, or the restrooms are out through the doors to your right and to the right there. These doors will be reopened to allow other guests to come back in, but we'll reconvene in about 10 minutes. Thank you.